Okay, I have the region in the first quadrant. Hopefully they graph it for us. Bounded by the x-axis, the graph y equals log of x and 5 minus x. Find the area of R. And there are two ways to do this. How do you want to do that, Jack? Do you want to divide it up horizontally or vertically? If I do it vertically, I have to write two integrals. But I can. And guess what? I need to do it horizontally for C because I know the problem. Okay, you guys, we're doing 2012. So you tell me. Horizontal? Okay. I'll have to get my calculator out. But we are going to slice it this way. Draw the slice. This is x1. This is x2. x1 is bigger than x2 because it's further to the right. Well, how do you find the area of that rectangle? I'm not even going to look at what my functions are because I don't care. It's the base. What's the base? If this height is this length, what's this thickness? Delta x or delta y? Delta y. They are never going to be the same. So if you saw anything about shells out there on the software, you can just forget about it because we don't do those anymore. So it's this one minus that one. That gives you the length. Does that make sense? Yes or no? Okay. I haven't looked at the functions. But this tells me I want everything in terms of y. So I want to solve this equation for this y equals 5 minus x. I want to solve for x in terms of y. What's x equal to? Can we do that in our heads? But be careful you do it right. 5 minus y, is that correct, you guys? Yep. Okay. The other one, well, to me is easy, but maybe not to you. This is y equals the log of x. Are we doing A or? We're going to do A. Because I'm going to integrate from x1 minus x2 dy, and I have to integrate on the y values. So I have to solve for x in terms of y. Because this tells me, so without the differential, I can get really confused. You have to have the differential. We will not mark off if you do not have it. But you probably won't set it up right. This is a calculator problem. So what is my big X value? That's pretty easy. It's the integral, and it's this one, 5 minus y, minus the other one. What is X here in terms of y? That's right. That's e to the y. dy. Is that okay? Yep. Get 1 point for that. Then you have to find out where they intersect. Where is the first rectangle going to start in terms of y? It's going to start at y equals 0 and go up to this point. Never assume, unless they tell you that point, never assume. We're going to have to grab it. Okay, so I have to bring my calculator up. Now, make sure you get fresh batteries for your calculator. You do not want to be looking at batteries in the middle of the thing. You need to bring both the pencils and pen. They will have extra pencils there. Uh-oh, cancel. Yes, they will, but that's wasting your time. Filling something out. I don't remember what. Yes, and I'll do it. Now, I can't enter it as x equals 5 minus y. I have to enter the original one. Okay, so preview of next year. Okay, so this is 5 minus y, x, I'm sorry. And then the other one is the log of x. No, that's x in terms of y. I have to put in y in terms of x because that's what my calculator is designed. What did you ask me? Now, they give me the domain, don't they? 1, 2, 3, 4, 5, 6. So my window, I will go 0 to 6. I'll scale it by 1. Y min, I'll go -1. I like to see the axis. And we're going to go up. That's 1. That's 2 looks good. And XRes, if you increase that number, it will graph faster. That's what that does. There's my line, here comes my log. Oh, I've got one of those little circle things. It's just slower that way. Okay, so you need to find out where they intersect. Oh yeah, you should have your calculator out. You should be doing this. So we are going to second, calculate, intersect. Now, if they give you that function, they ask you for the maximum, you still have to show the calculus. Even if you could graph it, doesn't matter. They won't give you any points for taking it off a graph. And this is not that bad to do. It only intersects in one place, so I just press enter, enter, enter. Now, that gives me the X and it gives me the Y. I want to keep both. Write down all the numbers on your exam. And what am I going to intersect this to? Let's call this one A and call this one B. Show you how I'm going to store them. I don't want to enter those numbers in my calculator. And I'm going to write this down on my paper. Why not write both X and Y just in case? Huh? I can't hear you. So you want to go from 0 to what? B. Okay. How can I do that? I don't want to remember that. It's too hard. So what we're going to do is we're going to store that. I've done this before. You probably forgot. I should really get this fixed. This is annoying. Okay. And we're going to integrate that. So in X, I don't know if I need it. I think I do for B. So I'm going to store that into A. So second, quit. Now, I'm going to clear that out. My X is where I last was on the screen. Same with the Y. If you don't believe me, press enter, and there it is. 3.693, whatever. And I'm going to store it. Do you see the store button down here? I'm going to store it into A. Well, that's in the alpha mode. Alpha, A. And then I'm going to put the Y value into B. And I think they do that on the scoring rubric. Pardon? So you have to find Y. It's alpha Y. Where's Y? 1, I think. If you don't believe me, I press enter, and there it is, 1.30. The minute I move my cursor, it's not going to be right anymore. So I'm going to press store. I could have just done Y store. And I'm going to put that into B. Okay. Now we're going to integrate. Alpha, Y. It's alpha, and it's under the 1. I can barely see it. In fact, let's do, and let me put over here. Okay, so let's go ahead and integrate that. And I'm going to clear that. I want a clean screen. And I'm going to go math, 9. If you have pretty print, it's a lot easier. And I put this, oh, I'm going to have to type that in there, aren't I? Shoot. Okay. Now, what am I going to type in here? I could do Y's. If I really want to keep it Y, I can. I'm just going to do 5 minus X. Minus E, second E to the X. I just changed them to X's because they're dummy variables. It doesn't matter. They're dummy variables. If you want me to type a Y in there and a Y there, I can. It's just harder. Okay, comma. My variable is X. I just changed them to X's because it's the same answer. Comma. 0, and I want to integrate to that 1.30, but I put that in B, so I'm going to do that. Alpha B. Where's B? Yeah, I can't see it. No, it's actually faster doing this. Plus, I'm more accurate. Because I'm teaching it. Wait, comma X. Oh, I need another parenthesis in there. I need a parenthesis around that. I would put it in Y1 or Y2 or something like that. Oh, I went too fast. Second, insert, parentheses. There we go. There it is. You get 2 integrals if you slice it vertically. It's no big deal. You can. And I have to slice it vertically for the next one. Yes, you'll get exactly the same answer. Do you want to know what those integrals look like? Okay, so it's the integral. I'm trying to find space here. I'm going to integrate, so for the x's, because I need that for the other one. I'm going to integrate from, where's my first x? 1 to a, and that's the log function, ln of x, which you cannot integrate by hand from this class, integration by parts. And it's going to be plus the integral from a to 5 of 5 minus x. Is that right? You will get the same answer. And I need that for B. Okay, and B has a lot of words, but that's okay. This is the region of my solid. You should not get different answers. Solid. Salad, too. Did I? There it is. Let's get some points here. Oh, they're there. I have to get the same answer. Yes, it's 0, so be careful. So you get 1 point for your integrand, no matter which way you did it. So you get 1 point for that. You get 1 point for finding these guys, basically, because that's your limits. And then 1 point for your answer. B. That's a B. Okay? So you should get 3 for that. Now we're ready for this one? Oh, you want me to go back to this? No. This is the answer here. Yes, we did get 3.69. Make sure, and you right now, if you're thinking about it, make sure you're in radian mode. If you have trig, you'll be in trouble if you're not in radian mode. So tell your physics people you got to be in radian. Hmm? Yeah. Did you put your stuff in B? Oh, it's X. It's got to be Y. If you're going to put Y's there, it's got to be Y. Sorry. Okay. It's 50-50. Yep. Yeah, let's do the next question. Okay. Because this is one of these cross sections. But don't let it bother you. Sometimes they give you the area of the cross section, which is really nice because of what's fine? Length times width times height. The height is that dx or delta y. So if they give you the area of the cross section, it's the area times delta x. Now, read this carefully. Perpendicular to the x-axis. Oh, that's a square, not even a rectangle. It's this length. There it is. How many of these do you have? You have 2 of them. You have to do this region here and this region. Perpendicular to the y-axis would have been easier. Just 2. Okay, do not evaluate. So how are you going to find this? This is the side, isn't it? So what's the volume for a square? Because this is a different function than that one. Well, it's a square, so it's side squared. And what's the differential if it's perpendicular? Read the problem twice, perpendicular to the x-axis. So it's d what? No, it's dx. Okay, so I'm going to go down here. What? No, what? No, it's perpendicular to the x-axis. Yeah, that's the side. I said this is delta x. Okay, and that was the log of x, right? Well, we kind of have it here. So you really need both of them for both of them. Okay, so we'll integrate from 1 to a, and it's a square. So it's that y value squared dx. Call it y1. And then this is from a to 5. Call that y2 squared dx. Well, that's the log. It's the side is this length, and it comes out at you. It's a square. If it were a rectangle and said the height was 3 times that, then it'd be 3 times s, isn't it? Well, they've got different problems. They're not always squares. Sometimes they're semicircles, too. Then you really have to do the geometry. They're in the multiple choice. We can. So what's y? The log of x. We got 2 days. Squared dx plus there's tonight. I know. Oh, yeah, I'm here in the morning. Okay, what's the other y value? 5 minus x. Squared dx from where? A to 5. I like the square cross sections. They're not that hard. You don't have any pies in it. Why? Because you didn't rotate. I think that's easier than the washers. So when you rotate, because you get circles. If you understand, you remember. That's right, donuts. These are square cross sections. They're coming out at you. What's the volume of my iPad? It's this length times that length. In this case, they're squares. My iPad is not a square, so they'd have to give me what that is. You have to do this rectangle and this rectangle. A is the, we intersected this is at A comma B. Okay, watch the video again. We found it on our calculator. Is the x coordinate? Right there. There's A, there's B. Yeah. Yeah, don't make this hard. Plus, we want to get through some more problems. Okay. I like these. Rotating that is a lot harder because it's harder to visualize. This, I don't care what it looks like. I take the cross section out and I find out what the volume of it is. It's just like a box, that's all. Okay, what's C? And C bothered people, but I didn't really know why. I did mine differently than the scoring rubric. But what we're going to do here is horizontal line y equals k, somewhere here. And it divides these two regions into equal areas. So I said the area of this one equals the area of that, or you could say that the area of this one is equal to half of whatever the area was from A. But they're both the same. So we could probably sneak C in here. What is the area of this? It's just area. So we integrate from 0 to what? K. No, it says don't integrate. We have it. We did it in A. What's this length? It's this side. It's this right here. 5 minus y minus e to the y dy equals, and it's half of this value right here if you want. Or could you integrate the same thing from k to, no, we're going up. It's the y's. B. You could do that too. It just says it's half of the area. We found the area. Or 1/2 of that number. We found it. So even if you have this number wrong, we get our calculators out, we check it. If you have this all set up right and you took half of whatever your wrong number is, you'll still get credit, full credit for that. Because that's just working off a wrong answer. That's it. Yeah. They don't take you, if you've studied, they don't take you 15 minutes in front. That's it. That's how you write it out. You either do this equals 1/2 or the area of the lower region equals the area of the upper region. Well, they're both equal to 1/2 of that. And that's what they did. Okay, so there's your squares. 1 to A is the log of x squared, y squared, and y squared. This one wasn't too bad. Yes? Nope, because it says the line is y equals k. You have to do it horizontally. That's why I said we might as well do it horizontally. We have to in C. And then do half of that. And I wouldn't even multiply that out. Who cares? Just leave it 1/2 of that area. Pardon? You want problem 3? It's not an area volume problem. We did this one, and this one we're going to have one like this. Well, you guys, I do have a video up on it. They're labeled what problem numbers I did, I believe, with the dates. What's G of 2? Well, it doesn't hurt to talk about it. Now, tonight, Mrs. Erzman will do start with 2010. I think it was. What's G of 2? G of 2. Well, I don't know what to do. So I'm going to put in 2 right here for x and right there for x. And I know what that means. Jack, what does that mean? What's that mean, that integral from 1 to 2? It's the area from 1 to 2. Here's 2. This is not too tough, is it? What is it? 1/2. The base is 1. And what's the height? Now, this is -1 here. No, this is -1. -1/2. So it's -1/4. Does that make sense? It's negative? Just the triangle. 1/2 base times height. 1/2 base height. Now, what we're going to do, well, we're going to fix it. What's G of -2? So G of -2 is the integral from 1 to -2 of f of t dt. Well, I got to go backwards, and I get all confused when I go backwards. So how about if we rewrite it from -2 to 1, then it's in the right order, but you remember what you have to do? Put a negative. I think it's easier for you. I can go backwards, but then you have to think, okay, going backwards, that's negative. The graph's underneath, that's negative, so that makes it positive. It's just easier to do this. And I think you'll get it right more often. So it's negative times whatever I get there. So from -2 to 1, I have to do this one, which is 1/2. What's the base here? 1. And the height is 3. Okay. Now, this is below the axis, so what's the sign? Negative. What part of a circle is it? 1/2. The radius squared, which is, oh, pi, I forgot pi. 1 squared. Leave that. That's all you have to do, and that's correct. Yeah. Because what's the area of a circle? It's 1/2 pi r squared. I'm going from -2 to 1. Because the integral's from 1 to -2, and I don't like to do it backwards. Because when I multiply this negative out, this is going to become positive. And when you went backwards, you're going to get the wrong sign because you're going to forget about that. Because it's delta x is positive. If delta x goes this way, it's negative. Direction matters. Yeah, there'll probably be some distance displacement too. Okay, now this is the second fundamental theorem. And if you know it, then this isn't hard. First, before you do g prime of -3, why don't we just find g prime of x? And it just says find the value. It doesn't say justify, but I just do justify. And just because they don't say justify doesn't mean they're not expecting you to write something down. Why? They want you maybe to write this. Maybe not. Sometimes you get a point for this. I find g prime, I'm going to take the derivative. What's the derivative of the antiderivative? It's just f of x. So g prime of x equals f of x. And if I were with you and we were taking the exam together and I could whisper something in your ear, I would say, what do you do? How do you find g prime? Not g prime of -3. How do you find g prime? How do you find g double prime? It's just f prime. So when you get stuck, just imagine I'm sitting there next to you asking those questions. And your answers will come because you know the answers. I know that. Okay. So what's g prime of -3? Well, it's f of -3. So g prime of -3 equals f of -3. Whose headset's so loud? Yeah, it's too loud. Turn that down or off. Okay. What's f of -3? You got to read it off your graph. And they're not going to make it 2.001. I mean, they're not going to do that to you. So that's 2. And what is g double prime of -3? That's f prime of -3. What's the slope at -3? Just count. How many is this? -4 to -2 is 2. 1 to 3 is 2, so what's that equal to? 1. Yeah, that was easy. Okay. Don't say that. What is that? Yes, he is. Yes. Okay, so there's my points. We got 4 points already. You only got to get 6, so we got to get 2 more. That's for 5. Come on, let's reach for the 5 as an average. Yeah. Okay. You're at a 3 right now. You're borderline 4 if you can get some more points. We haven't tried. We haven't looked at the next question. Whoops. Okay, whoops, wrong way. Find the x-coordinate at which the graph of G has a horizontal tangent line. Now, and does it say, it says justify all your answers, really. If you have a horizontal tangent line, what's true about the derivative? G prime has to equal 0. What is G prime? Because I wrote it down. G prime is F. So F is equal to 0. Identify all the candidates. Where's my function equal to 0? X equals -1 and 1. Sorry. Okay? Carter, is that okay? And then it says, is that a max, min, or neither? To have a max or min, the derivative must do what? Change signs. I don't care which way it is, but it's got to change signs. Okay, so F changes signs at -1 and at 1. Oh, it doesn't change sign at 1, does it? So that's a neither. And all you have to say is no sign change. That will get you the points. But you have to tell me if it's a max or min at -1. My derivative is positive, and then it becomes negative. Well, think about what's this tell you about the function? It's increasing and decreasing, so it's a max. How do you say it? F prime goes from positive to negative. I think that's 3 points. It's 3 points. Saying the G prime is 0. Yes. Nope, you do them all. Okay? Another point for finding them. Well, if you don't know G prime is 0, that's a problem. But if you know that, then that's easy. So we've got 7 points out of 9. Pretty good. And then you have to answer it. So let's say I don't have time to answer why. I'll just do that. It's good enough. Okay. Now, on the open interval, find all, but D isn't hard at all. Find all the values where G has an inflection point. Explain your reasoning. How do you know? Jacob, how do you know you have an inflection point? What are we looking for? I want you all to get this because this is easy. Nope, it's not it. I always mark that wrong. Second derivative changes sign. Please know it's. Do you see why I get particular in the beginning of the year about the vocabulary? Because now it's too late to learn everything. We've got to get it as we go. Always preparing you for the exam from the very beginning. F double prime changes sign. Now, what is F double prime? Yeah, in this case, it's G double prime. And so in this case, it's F prime. So look at your picture. Now, by the way, you get a point for that, even if you don't identify the right points. That's okay. I think. Where does... I'm sorry, what? Okay. Now, where does the slope of this line change signs? At -2? It's still negative going down here. Negative, 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 and whoops, I missed one. Because it's negative and then it's positive right here. 0, and it's positive, and then it's negative. So there's 3 of them. -2, 1, and 0. Whoops, where did I write that? Okay, if you miss one, you still get you still get this point. I wrote it. I did that first. I always do the reason first. because the reason tells me what to look for. Does that make sense? It always tells me what to look for. So you know that. Okay. Should we do 2011, the other area, volume 1? I think this one has washers, and I think it's rotating around something other than an axis. If it's rotating around an axis, it's easy, or easier. If it's rotating around a horizontal or vertical line, it's not easy. Can we just check it out? No, it just says, you know, test lines don't give you any points, by the way. You can if you want, but I can see it changes sign. Now, let's see, 2011, this will be question 3 or 4, I think. And Mrs. Hersman will start with 10. There it is, 3. Now, this was a non-calculator one. Hasn't been non-calculator for many years. Which means that it's got to be easy to integrate. Because that's not what they're testing. They're testing, do you know how to do the problem? Now, you guys have to know equations of tangent lines. You need to know it cold. Okay, Carter? What is the equation for a line? Y minus y1 equals mx minus x1. And please, if you're finding the slope, that you get it in the right order. It's the change in y over the change in x. I graded a lot of them that had upside down. You need to know the y and the x and the slope. Somehow they have to give you enough information to find that, and they do. Okay, so we have the sine of pi x here. That's this little guy. And the other one is 8x cubed. Now, integrating sine of pi x, you have to be careful. You might have to do a u substitution. Okay, I want the tangent line for A at x equals a half. So it's y minus f of a half equals f prime of 1/2, and it's x minus a half. Now, it might not be x and y. It might be the waist problem or the baby bird problem. It depends. Okay. Now, which one's f? Oh, 8x cubed. Can I find f of 1/2? Is equal to 8 times 1/2 cubed. Well, and you can leave it like that if you want, but you aren't going to want to. It's what? 1. 1/2 is 1/8. 1/2 cubed. Okay. So that's 1. What's f prime? 16x squared. That was easy. What's 24? Oh, 3 times 8. Oh, I'm not doing well, but anyway. Sorry, 20. Don't ask me why I did that, because I did squared. Okay, and then we're going to put 1/2 in there. So it's 24 times 1/2 squared. Personally, I need to see it, especially if I'm tired. It's 4 into 24 is 6. So y minus 1 equals 6x minus a half. That was it. I like these problems. But I have a feeling it's only 1 point. Oh, it's 2. They put the 1 on the other side, and that's the reason for that is because of the BC calc. You don't have to. It's fine. You can do y equals mx plus b, but I think you're crazy. Okay, that wasn't too bad. Find the area of R. Which way do you want to slice it? It really doesn't matter. Vertically or horizontally? Let's do it vertically. Okay, so that's going to be delta x or delta y? Which axis? It's delta x, and it's going to be y1 minus y2. Okay, so we are going to integrate. The sine function is first, the sine of pi x minus the other one. I want to write it down right, 8x cubed dx, and we will integrate to where they intersect. Guess what? They told me where that was. That's nice. Otherwise, I have to figure out when the sine, and that would be guess and check, because you can't solve that. Yes. Nope, they don't mark off of the dx's. Now, the next question is, do you know how to integrate the sine of pi x? What's the antiderivative of the sine? Negative cosine of pi x. Now, check. What is the derivative of the cosine, negative cosine of pi x? Positive sine of pi x times what? Chain rule. Don't forget the chain rule. Times what? Pi. But I don't have a pi there, so what do we have to do? Divide by pi. You could do a u substitution if you'd like. U equals pi x. So du equals pi dx. So dx equals 1 over pi du. Evaluated at 0 and 1/2 minus, and what's the antiderivative of 8x cubed? 8x to the 4th over 4. Evaluated at 0 and 1/2. You must evaluate. It's not good enough. It's good enough for some points. And that's 4 points for that. Because I have to integrate the sine of pi x. So I only know the integral of the sine of x. So I'm going to do a u substitution, call it pi x, then du is pi dx. So solving for dx, it's 1 over pi times du. You can only, remember that list of derivatives and integrals I gave you? That's all you can integrate. That's it. So I integrate this. This is the sine of u. Dx is replaced with 1 over pi du. So it's 1 over pi negative cosine of u. Let's go back to pi x. And then we will evaluate it at 0 and 1/2. Now, let me finish this thought because we're going to run out of time here. But it's negative 1 over pi cosine of pi over 2. Do I have to evaluate this on free response? No. Minus a negative 1 over pi cosine of 0. I know what they are, but you don't have to tell me what the cosine of 0 is or the cosine of pi over 2. By the way, that's 0. And that's 1.
Let's go messy. What was the answer to A? Right there.
1 point for your derivative, 1 point for your answer. Here, you get a point for, here you get a point for this. Here you get a point for each antiderivative. So you could get 1, 0, 1, and my bet is you get 0 for the answer. Because you miss this point, you're going to miss this point too.
But for A, what was the answer?
It's right here.
Oh.
I did y minus 1. But once you put in your values, it's okay. You don't have to find the cosine of pi times 1/2. And that was 6 points out of our problem. Then tomorrow we'll start with the finishing this problem up.
When can you do like quiz corrections and stuff so I can get points for that?
Tomorrow morning?
All right.
No, the second.